4 supersonic bombers built for the end of the world just got a new job. Sink ships. Not one ship. Not in theory. In practice, with a live missile wired directly into the belly of the aircraft on a runway in Texas. And what happened during that test just quietly rewrote how fast America can arm its bombers for war at sea. On June 2nd, 2026, at Dyess Air Force Base, they connected a live anti-ship missile to a B-1B bomber without ever loading it into the bay. It's called Event Zero, and it just changed how fast America can upgrade its bomber fleet. Here's why this matters. The AGM-158C, LRASM, the long-range anti-ship missile, is one of the most dangerous weapons in the Pentagon's arsenal. Stealthy, autonomous, able to hunt enemy warships from over 560 kilometers away, even when GPS and communications are jammed. But every time that missile's software gets updated, the Air Force normally has to load a live round into the aircraft just to test it. That's slow, that's expensive, and in a fight against a peer Navy, slow gets people killed. So a maintenance crew at the 7th Bomb Wing built their own solution, literally built it. A custom interface cable made in-house to U.S. Navy specifications that lets engineers talk to the missile from outside the aircraft. No bay loading required. If you think American ingenuity still wins wars, type bone in the comments below. Welcome to American Lethal. A single software update to a single missile used to take months to certify, sometimes longer. In a fight against a modern Navy, months is an eternity. So what if you could cut that down to days? What if a handful of airmen with a custom-built cable could do what used to require an entire test campaign? That's exactly what just happened at Dyess Air Force Base, and by the end of this video, you'll understand why the United States Air Force is calling it a turning point. This is the channel where we go deep on the aircraft, the weapons, and the people who keep American air power ahead of everyone else. If that sounds like your kind of channel, you're exactly where you need to be. Let's start with the aircraft at the center of this story, because it deserves the introduction, the B-1B Lancer. 4 engines, variable sweep wings that fold back for supersonic dashes and spread out for long-range cruise. It first entered service in 1986, built during the final years of the Cold War as a nuclear-capable penetrator designed to slip past Soviet air defenses at treetop level. That mission disappeared when the Cold War ended. The B-1B did not. Instead, it evolved into something the Air Force actually uses constantly, a conventional long-range strike bomber capable of hauling up to 75,000 pounds of weapons across 3 internal bays, at speeds pushing Mach 1.25 over an unrefueled range past 9,400 kilometers. That's nearly 5,840 miles without touching a tanker. 4 General Electric F-101 afterburning engines give it the kind of raw thrust that turns heads even today, decades after it first rolled onto a runway. But here's the thing about the B-1B that most people don't know. It's not just a bomb truck anymore. Since 2018, it's been America's first and only Air Force platform certified to carry the AGM-158C long-range anti-ship missile, known as LRASM. And that single fact quietly turned an old Cold War bomber into one of the most important ship's killers in the entire U.S. arsenal. So why did any of this matter enough to build a brand new test procedure around it? Because the world changed, and fast. China has been building warships at a pace the U.S. Navy hasn't matched since World War II. Its Navy now fields more hulls than America's, backed by an integrated air defense network designed specifically to keep American forces at arm's length. Defense planners call it anti-access area denial, or A2AD. In plain terms, it means get close enough to strike our ships, and we will shoot you down long before you get there. Against a threat like that, you need a weapon that can be launched from far outside the danger zone. That's exactly what LRASM was built to do. The AGM-158C is not a simple missile. It's derived from the JASSM-ER, a stealthy low-absorbency cruise missile already trusted across the Air Force. LRASM takes that airframe and adds something extraordinary. Passive sensors, imaging infrared seekers, advanced electronic support measures, and autonomous target recognition software that lets the missile find, identify, and strike an enemy warship on its own, even if GPS is jammed and communications are cut. With a range past 560 kilometers, over 350 miles, and a 1,000-pound penetrating warhead, it's built to hit hard, hit smart, and hit from a distance that keeps the launching aircraft out of the kill zone entirely. Now, here's where the story gets interesting, because building a missile like that is only half the battle. The real challenge is keeping it current. Modern precision weapons don't stay static. LRASM receives regular software updates, refinements to its targeting logic, its sensors, its communication with the aircraft carrying it. Every single one of those updates has to be tested and certified before it's trusted in combat. And traditionally, that process was slow, expensive, and rigid. You'd load a live missile into the internal weapons bay, run the full validation sequence, and hope everything checked out. It worked, but it was heavy, time-consuming, and it tied up aircraft and personnel for extended stretches every time the software changed. That was the problem the Air Force needed to solve, and on June 2, 2026, at Dyess Air Force Base in Texas, the 7th Bomb Wing solved it. They called it Event Zero, and what made it remarkable wasn't just what they tested, it was how they tested it. Instead of loading a live missile into the weapons bay for the full traditional sequence, engineers and weapons specialists connected a live AGM-158C to the aircraft through a specialized interface cable built to U.S. Navy specifications, fabricated entirely in-house by airmen from the 7th Bomb Wing's weapons back shop. Think about that for a second. Not a contractor, not an outside lab. Airmen on the flight line building the exact piece of hardware needed to validate one of the most advanced weapons in the American arsenal. With that cable connected, the team verified communication between the aircraft and the missile with its updated mission software, gathering baseline performance data without ever needing the full internal bay loading procedure. It sounds simple. It wasn't. Every handshake between aircraft and weapon had to check out. Every line of updated code had to behave exactly as designed. One failure and the whole concept doesn't hold up. It held up. And here's the twist buried inside this story that deserves more attention than it's gotten. This wasn't a flashy new aircraft unveiling. There was no ribbon cutting, no dramatic flyover. It was a handful of airmen, a cable they built themselves, and a live missile connected on a runway in Texas. And what they proved that day will shape how quickly America can arm its bombers against every future threat that comes next. That's not a small achievement. That's the kind of quiet, relentless innovation that keeps the United States ahead, one validated line of code at a time. If this video gave you a new appreciation for what it takes to keep America's bombers ready for tomorrow's fight, hit that like button and subscribe.